Thanks everyone at HackFest for joining me at Hacking Serverless Applications. I call it the treasure map for uncharted water because there isn't a lot out there in the internet. So it's kind of hard to understand what's going on. Why is it a thing at all? So who am I and why am I here? So my name is Tal. I'm dealing with application security for a lot of time, almost 20 years. Recently, I was part of two startups, Protego as head of security and Cloud Essence as a co-founder. Both startups dealt with serverless security. Both startups were acquired. And then the reason I'm here is because I have, in the past, let's say 5-6 years, I've been dealing with serverless, almost alone. If you want to reach out after this talk, you can always find me through Twitter, LinkedIn, or however you want. Okay, so why do I think it's necessary to talk about it? And especially now, it's because serverless, as you can see in this graph, trend graph, has been getting into more and more into the mainstream of application development, apart from the COVID part where it breaks a little bit. But if I try to look for serverless security, I don't find anything. I mean, based on terms, on trends through Google, it's practically me and someone else, or me from two devices, I don't know. But not many people are really talking about serverless security. So this is why I think it's important. And I'll try to show, in this talk, I'll try to show some ways of hacking application built on serverless. But before we dive in, what is serverless? So I took a picture from one of our customers, or his diagram of the serverless application, how the system, our system sees it. This is actually quite, maybe one of the smallest applications. And there are maybe a couple of dozens, maybe 100 of Lambda functions, where Lambda function is the compute power of this architecture. But you can see that basically there are many different resources that the only way that they are actually connected together is because of some kind of a logic and configuration that you built in the cloud. But it's not a monolith as we knew it. It's not one single business logic built into a web server with one big flow. No, those are different resources which you create separately, and then in some way, probably through infrastructure as code, you configure them to move parts between them. This is how you create the logic. The architecture is different. The cycles are also different. Of course, it's not a waterfall, but it's not even an agile. It's maybe a DevOps, DevSecOps, or even hyper agile, where actually developers push into production few times a day. I'm not a developer per se, but even myself, I almost on a daily basis push code into production. So it's also hard to keep up as a security team, to keep up with what's going on. You don't have those processes where you just stop a version and you say, okay, now we have version 1, version 2, and we can pen test this version and see that it doesn't have holes. And then we ship it back and developers fix it. And then we have a complete secure version. It doesn't work that way anymore, at least. We have to keep the security as part of the development process. This is why it's called DevSecOps many times. And in order to do that, we have to automate everything. Because if we are unable to automate, then it's going to be quite hard for us to get there. Based on what I told you so far, it also means that many security decisions are taking bottom up, not top down, security decisions and development decisions. So many times you will give the developer a lot of power into the security posture of his code. Of course, secure coding is something that exists many years, but in this case, it's not just secure coding. There are other aspects as well, and which we will talk throughout this talk presentation. Okay, so what is Lambda function? Or Lambda function is basically AWS's cloud function. You have Azure functions, you have GCP function, cloud functions, you have other function as a service, if you want to call it, like FAS, from various and different vendors. The main ones are AWS, of course, with Lambda, and Microsoft Azure and GCP. Of course, those are the main vendors. So the way it works is that it's more of an event-driven architecture. Something happens in your cloud, and that triggers your code, your function. And this function performs the process on the data or whatever that is, the metadata or the event itself. And within the code, it tries to communicate with other services, whether in the middle or at the end of the code, maybe to write the data into a database, send an email, register an event, do analytics, upload files, whatever that is. But of course, if you have this function in the middle where you process the data, is where you're going to put your code. And if you're going to put your code, that probably not you, but you, some of you, or some of us, or some of everyone, because we are not perfect, we're going to make mistakes, and those mistakes are going to cost us in security issues. What those security issues are, what I can do with them, we'll talk about it. Okay, so what are the challenges? Why is it different from a traditional monolith application? One of the things is the loss of perimeter. We don't have anymore one way into our application through the network, a load balancer, an API, a REST API, or whatever that is, that we can put the security controls at. We can put your web app WAF, or we can put some controls to make sure we have authentication and access control, and everything goes through that network, and we can control all the flows from a single point of view. It doesn't work that way anymore. Now we have resources in the cloud. They're in the cloud. That means that they're theoretically accessible to anyone, unless, of course, you make some security configurations, policies, and roles and assignments into those services to block other people from reaching out. VPC, or a policy that check your organization, or check your ID, or have some kind of a authentication service in the middle, but you have to make it for each of the resources that you create. It's not a single entry point. You don't have the perimeter anymore. Those events that come and will trigger your code can be file uploads, file downloads, deletion of file, whatever that is. So file manipulations can be analytic processing, can be database, modifying data in the database, or changing data in the database, or entering data in the database. Could be logs processing, could be code commits, could be many things, could be, of course, API, or very common SNS, or notifications, emails, whatever you can think of can get someone or this event access to the code directly. And you don't have the control between the service that runs your code, or the event that triggers your code, to your code. You don't have this. You only have the code. So you have to make sure that the code can somehow protect itself in some ways. And maybe the most challenging part of, the most challenging parts of securing serverless-based application is the policies, the IAM, the identity and access management, to the code or to the resource that we built in the cloud. It's hard because there is no, as I said, there is no single entry point where you can put it. So you have to create the policy, the IAM policy, if we're talking about AWS, to secure these resources. Sometimes it could be easy. We have here a code, a Lambda function with a very short 20 line of code, where we can see that the function is doing put item, which is the API to write into a database. But the policy says that the function has a DynamoDB, which is the name of the service. The DynamoDB is a NoSQL database, and star means every action. So this function has theoretical permissions to run any action on the database service and on the resource star, meaning any table. Any table. It doesn't even have to be a table of the microservice. It doesn't have to be the table of the application. It can be a completely different application, completely different environment, as long as it sits under the same, in this case, account and region. This function has permission to access it. But when I say has permission to access it, I mean the cloud will not block you from doing that. But if the code doesn't do it, why do I care? Because there are ways that attackers can reach the environment and steal the permissions, the keys of the Lambda function, and then perform those activities from their own computer with the same permission of the function. So in this case, what I would want it to be is to say, okay, this function doesn't have to be DynamoDB star, but it does have to be DynamoDB put item on a single table, in this case table. Of course, in 20 line of code, it's very easy. You can even do it manually. But when you have hundreds of lines of code, if not thousands, and you have thousands, if not 10 or 100,000 of functions, it's kind of a hard process to do it manually. And Lambda functions pop up like if you give the developer access to run on Lambda functions, you will see that, or functions in general, you will see that functions will start popping up in your account because it's easy. You can run 50 lines of code to perform an activity, click, push, and you have another function, another 50 lines of code that does another activity, another action. You again, you deploy, it's in the cloud. It's in the cloud, it can run, it can even be in production. So it's kind of hard to stop them once you're giving them the permission to do it. And we go to customers sometimes and they say, yeah, or prospects, yep, we have given our developers a green light to use functions. So we are just starting to think about a serverless security solution. This is why we're trying to listen up. And we were asking them, okay, how many functions do you have? Do you know? Yeah, we just started. So we have maybe 50, 100, 200, if we count all the accounts together. We give them a script and you tell, run the script, and then they see that they have thousands of functions. Because again, once you're giving them the green light, they'll start popping up. Anyway, so it's kind of hard to automate or to do it manually, and you have to automate. So this talk, I'll try to go through multiple type of entry points to show you how maybe not traditional it would be for someone to attack functions that are configured in the cloud, that are misconfigured, or that are vulnerable in the cloud. All you need to know is the way or the right access to them. Sometimes they're public, completely public. Sometimes they are less public, but you can still access them. Okay, so It's called, sometimes it referred to as an event-based event injection or something like this. And there are various of ways in which we can reach the code, the function. We can attack code that is connected, or functions that are connected to REST APIs, attack functions that are connected to third-party applications, to cloud storage, to authentication service, IoT devices. We'll show one. Email service, notification service, code, and many, many more. If you'll try to go through all the three, just the three, because there are many, cloud provider, and see all their trigger types, you'll see that you have a couple of dozens of different entry points to your code, meaning there are different types of events that could happen and access your code without you being in the middle, you as the security team of your organization. Okay, so the first attack vector that we'll talk about is API, or third-party application. Actually, in this case, I'll use Slack as a demo. It's not a vulnerability in Slack, it's a vulnerability in your serverless application. For maybe multiple reasons. One would be too many permissions. The second would be, in this case, a vulnerable dependency. Okay, so we have a user interacting with Slack through a Slack channel. The Slack channel uses Slack, of course, API to communicate with an application that I predefined before. So through a webhook, in this case, or a web API, to go through to my cloud's API gateway that will trigger the Lambda. The Lambda will then write or read, depending on what it does, from a database and bring the results back to the user. Okay, so let's see the demo. So here on the top part, I have the Slack chatbot. On the second part, on the lower part, I have an HTTP tunnel I have on my computer. It's called ngrok. It's just a free, or depends, you can have premium plan that tunnels network into your computer through HTTP. So I have a Slack bot where I can just write messages to maybe a sales channel, or automated support, or something like this. After investigation, of course, there are ways to do that, but let's leave the investigation part aside. Let's assume that I found out that this function, I started throwing some inputs, and I found that it is vulnerable to some kind of a known attack. In this case, it's node serialized library. Anyway, so I'm sending some payload here. You can see that I'm trying to run a child process with some kind of a HTTP, a curl request, right? So maybe to bypass some filters, I'm going to cut it into, split it, and then you can see that on my computer, I got task request. So now I'm going to change the request and try to do something else, like ls. And I can see that the name of the file, if I'm running ls on the local, on the current location, is index.js. That's great. Let's try to read index.js. Of course, for ease of use of processing data through network, I used base64 just so I'll get the entire code without spaces or anything. So I'll just copy that base64 code and decode it on my computer, and I will get back the code. And that's it. Now I have the code of the function, and I can see that it actually interacts with Slackbot, right? And it has DynamoDB, put item, as you can see, and we talked about it before in the demo. And I showed you that the function communicates with DynamoDB. So you can see here, DynamoDB, put item, and I have the table name. I don't actually need to know the table name because the code just uses an environment variable. And then it writes an item. The item is the user, the timestamp, the message, and the response. All right, great. Why is it interesting for me? As you can see below, I can also have the bot token and the username. So I can actually now interact directly with the chat and with the database as well. So now I'm going to do some more hacking into or trying to steal more data, like post-exploit part, where I want to steal data. What is interesting to steal? Well, in this case, I can steal the source code, I can steal the keys, and I can just run scans, or I can just read or write to the database. Let's see. So I'm trying to do a client. I'm creating a DynamoDB client, and I'm using the environment variable that already exists in the code. I don't need it. And then I'm trying to just read back. Of course, I'm sending the bot token and the username, so I don't need to go through the Lambda anymore. I can just directly talk with the Slack API back to the channel. So now I'm trying to read the first 5,000 characters from the database. And I don't need the HTTP channel anymore. I can just post back directly to Slack. So you can see here, I got all the message, and I even changed the icon of the chatbot. This is it. So in this case, what did we learn here? Well, Lambda functions run maybe a short amount of a small amount of code, custom code, but they use, sorry, just a second, but they use a lot of dependencies to do it. Some dependencies can be vulnerable, of course. And in this case, the function has too much permissions. Even though it would just write to the database, as I showed in the example, I could also read the data from the database. Okay, let's move on. Next attack vector is storage. In this case, would be I'm talking through an application to an API gateway. The API gateway has a Lambda behind it. This Lambda gives me a signed URL, so I can directly talk with the S3 bucket and upload file. Then the function can read the file and process it. Okay, let's see the demo. This is a vulnerable by design application. I'll talk about it later. It's called DVSA, Damn Vulnerable Serverless Application. I wrote it and it's completely open source. You can use it to learn, but we'll talk about it later. So I have a contact us page, of course, and it allows me to upload file or send feedback. So I'm going to attach a file, can be any file. So that's easy. So I'm going to upload a picture, and I can just so I'll see the process. So I can see that I upload the file name, and then I get a signed URL. And then when I click submit, it's going to directly send a request to the S3 bucket to upload the file, and then I'll get a thank you message back. So in this case, the function is vulnerable to command injection through the file name of the file that I'm going to upload. So in this case, I'm going to send back, again, using HTTP curl, a request that will send me the env data. Env will print the environment variables. The environment variables hold, I think in all the cloud provider hold information about the permission or the access of the Lambda or the function in the cloud. So in this case, I will have the Lambda keys back to my computer through this Ngrok HTTP channel, and then let's see what I can do with that. So I'm uploading a file. I got a link to directly upload to this S3 cloud storage. and I got some request back, response back. Should be the environment variables, right? So I got all the environment variables. I only need a part of it. So I need the access key, I need the secret access, and I need the session. All right, so once I have those three params or environment variables, I can start running AWS, in this case, AWS CLI. And in the AWS CLI, I'm going to use the keys that I just stole to interact directly with the cloud, right? So I don't need anymore to go through the Lambda function or through the application. From now on, from that point on, I can interact with the cloud directly and steal data. And you can see here, you can see all the buckets in the account, all the buckets in the account. Not sure I'm going to have access to all of them, but I'm going to start trying to access some of them. And as you can see, I'm starting to move on folder by folder until I get the file names and I can get an object. And again, I can get the object because the permissions of the function allow me to access files. If not, I would have been blocked and get access denied. Okay, so I downloaded a file from the bucket, even though I shouldn't have. The bucket is not public for read, just for upload. Maybe authenticated, but anyway. And I can change the order to whatever I want, or I can do whatever I want. Basically, I can change files, and in this case, I will upload back the file again, call and say, hey, I paid, I didn't get the order, or I can just read sensitive files, which we'll see later. All right, so just for the sake of the example, I'm going to run this, and when I'll query the bucket again, I'll see that the file is here. So I uploaded it successfully. Okay. Next vector. So we've seen APIs and cloud storage, and in this case, I have an email service. So we have here an email service, automated email service, where I upload my call or a talk submission proposal for for a conference, and it is uploaded through an email. It stores. There is a function that stores the data is uploaded directly to an S3 bucket, and there is a file Lambda function that reads the file, process it, reads it, and send me back notifications. All of this is, of course, automated. Let's see the demo. Okay, I'm using ProtonMail, just secure email client, and I'm sending my talk to Fiction service. So I'm going to upload an innocent submission or a normal submission of a PDF file. And after a few seconds, I'll get an automated response. Thank you for my fake DEF CON submission. Okay, now I'm going to, just for the sake of trying, not because I'm evil, I'm going to upload a malware. Let's see what happens. So I upload a malicious file. It's just a malware file. It's not, it's embedded in the PDF, and I'll get back a response saying that thank you, but the file was submitted, was identified for malicious, and there is a link where I can get see the data for the submission, for the file. So now I say, okay, they process the file, they've scanned it, maybe there are some vulnerabilities I can take advantage of. So I created a specific POC where I download code. So basically I get full code. And in this case, I'll show it through the file, of course, upload, and then the code will run. We'll send an email to some email with an acceptance. Of course, in this case, is an acceptance message where your talk was accepted. And if you want to get your money or honorarium, then click on the phishing link, right? Okay, so this is what I'm going to do. And then I'm going to do another thing, which is even more severe, which I'm going to make the bucket public. The bucket is closed for, it just allows you to upload files. You cannot read other people's submissions, of course. But with this code, I will be able to get the bucket and change the permissions to the bucket to make it public. And then read all the submissions of all the participants. Let's see. So zipping this code, and then I'm uploading it to my own bucket. This is my own bucket, just to host it on the internet. And then now I will send a file that will do a curl to download the code, download and run the code from this my own bucket, my own server. Could be a server, it doesn't matter. And this is the submissions bucket, the bucket that, or the storage that hosts all the submissions of everyone. And you can see that when I try to reach it, it gets access denied. Now I'm going to do a submission with the file, malicious file. Okay, the code will also send me some notifications along that throughout the process, so I'll know that it worked. I get in it, and phishing email sent, and bucket was hijacked. I sent to myself. All right, so first I got the auto reply, then I got the thanks, great news from DEF CON, you got accepted, and you can click on phishingsite.com where you can get your money back, your money for your talk. All right, cool. This is the funny part, but this is the sad part, where I can just now see all the submissions of everyone that uploaded a submission to this event. And of course, I can also access them. Okay, yeah, this is a submission conference, and maybe it is more sad than funny, or I don't know, but it's not a complete disaster. It's not like someone accidentally changed your bucket containing all the data of your clients into public and then published it. Well, that could happen. Okay, so we've seen some more traditional, maybe still not super traditional, but maybe more traditional attack vectors. This is something that you wouldn't see on a normal application, just because it usually doesn't run this way. All right, so here we have a user, and we have an Alexa Echo Dot. Behind it, there is another Alexa skill, is a service from AWS, where you can configure your Alexa response for your application. And of course, there is a Lambda function, in this case, behind the scene, that interacts with the data coming from the speech, basically translating speech to text, so it can interact or use it as data, and then read data from the database and bring it back. There is a video on YouTube, of course. I don't know if you are able to hear. I hope so. Otherwise, it has no meaning. Let me.
Alexa, start Hack Me demo.
Welcome to Alexa, the hacking assistant demo.
What is my balance?
Please identify yourself.
Lisa.
What is your secret ID?
2018.
The balance for account ID 2018 is $15,000.
What is my balance?
Please identify yourself.
John.
What is your secret ID?
1337.
The balance for account ID 1337 is minus $500.
What is
Of course, this is simplified. It's just a proof of concept, but I'll tell you after this, when we finish this, that it wasn't actually, I didn't manipulate it, almost anything.
my balance?
Please identify yourself.
Admin.
What is your secret ID?
1007.
Sorry, you are unauthorized.
What is my balance?
Please identify yourself.
Test.
What is your secret ID?
1234 or true.
The balance for account ID 1234 or true is $1,250,419.
Stop demo.
Okay, so I got the first line from the database. The thing is here, all I had to do on my Alexa skill is convert numbers from text back to numbers, so I can use them as integers instead of strings. That's it. And it worked. I just used a demo. I did a demo where I talked to Alexa and I was able to do an SQL injection, a simple one, yeah, a very simple one, but it's something that you don't expect because when you talk about traditional monolith application, usually you don't think about events coming from sources like voice commands. In the cloud, it's very different. Okay, so why we don't hear a lot about things in the wild? Well, because maybe there aren't many, but maybe also not a lot of people tell you about it, or not a lot of people talk to you or say that they specifically had Lambda function. All right, but after all, it's an application. So log4j, log4shell. We all heard about it. Does it apply to serverless, for example? Well, it could, but you wouldn't know because it's still a log4shell. But here we have an example of a Lambda function that has log4j, uses log4j, and as you can see here, I'm just going to send it an event that contains the payload, the traditional, I'm saying the exploit, and it will send back whatever I want. And in this case, it's going to be the access, the keys for me to interact with the cloud. And again, from this point on, I can interact with whatever the Lambda can do from my own computer. We're almost done. One more slide. So if you want to learn more about serverless security, we have a few things. One is CodeSec is an open source project by Contrast. It can scan your functions and give you some insights about your security of your posture of your Lambda functions, the permissions, and if there are CVEs and so on. But there are also projects where you can just open source project, we can just go ahead and learn about serverless security. One is the OS Serverless Top 10, a designated top 10 for serverless. And the second one is DVSA, and then vulnerable serverless application, where you can in one click install and practice both secure and attack of serverless application. Just make sure you don't deploy on clouds where you have sensitive data. That's it, everyone. Thanks for joining me. If you want to learn more, of course, you're more than welcome to reach out to me at any time. My name is Tal, and I appreciate everyone that joined here today.